Hi everyone, today we're going to be talking about topic 1.8, valence electrons. This is the last topic in Unit 1. So we've been learning a while about these periodic trends in the last class, and so another, a few more trends, I suppose, are that elements in the same group, in other words, going down the periodic table, have the same number of valence electrons. And a result of that is that they tend to want to gain or lose the same number of electrons. So for an example, nitrogen, for example, has 5 valence electrons. Phosphorus, also has 5 valence electrons, and they both tend to gain 3 electrons, Both of them want to take 3 electrons so that they can get a complete octet. They're in the same group, and so they have that same trend. They both make the same kind of anion. And so if we look at this in the context of the entire periodic table, over here in kind of the S block, we have +1s and +2s, Our alkali metals on the leftmost column, they like to make +1, whereas our alkali earth metals, beryllium, magnesium, calcium, that second group, they like to make +2. If we go to the other side, this first group right here, boron, aluminum, gallium, indium, they all like making +3. This one's a little weird. I'm going to highlight it in blue, But when we get over to carbon, these can make +4 or -4, but they also tend to not fully ionize. And so what I mean by that is they prefer to make covalent bonds over ionic bonds, although occasionally you will still see some ions of those elements in +4, but these can either go +4 or -4, either way. Then we get over to the rest of our P blocks, We have these here. These like to form negative charges, And so nitrogen, phosphorus, arsenic, those like to form -3, oxygen, sulfur, selenium, those -2. When we get to our halides, fluorine, chlorine, bromine, iodine, those are always -1. And then our noble gases are 0. They don't like to make any bonds, and so you don't really make ions out of them. And so if you look at our periodic table, this is generally the trend of how these different atoms like to ionize. So here's just a few little practice problems. Magnesium and oxygen react to form an ionic compound. Write the molecular formula of that ionic compound. And so if we look back at our oxidation number periodic table, we can see that oxygen likes to form -2. And magnesium, because it's in that second group, likes to form +2. And so for magnesium and oxygen, that ionic compound, that chemical formula, would likely be MgO. They're each -2 and +2, so you should have one of each there, and that way you have a neutral compound. Calcium and chloride react to form an ionic compound. Write the formula of that compound. And so if we look at calcium, that typically forms a +2, that it's on the second group, so it normally has a +2 charge to it. And chlorine, that is all the way to the right, so it likes to make -1. And so if you want to balance this chemical equation, we will need 1 calcium, That'll be our +2, and 2 chlorines, and that would be our neutral compound there. We're always looking for a neutral compound. And then write the electron configuration for a phosphorus ion. Remember, when we have ions, we need to consider whether or not it's gaining or losing electrons. For phosphorus, that typically likes to form a -3. So if you have a phosphorus ion, it's going to gain 3 electrons. And if we write our electron configuration, we'd have 1s2, 2s2, and then 2p6, 3s2. And then normally phosphorus would be, I'm going to write this in red, It would be 3p3 for an atom of phosphorus. But because we have our ion, in this case, it's gained those electrons, so it's 3p6. Now here I have one last example. This one's directly from AP Classroom, but what we're looking at is ionization energy. You're told that this is the ionization energies of this element X, and it's asking you what is the most likely empirical formula of an oxide with element X. So if we look over at our periodic table, oxygen typically forms an ion of a -2 charge. And if we look at our ionization energies here, right, these three are all pretty close to each other. And if we look at the fourth and fifth ionization, we find that these are extremely high. And so likely this is forming an ion of +3, right? Because those first 3 electrons are relatively easy to remove, whereas the last 2 are going to be very difficult to remove. And so for X, this likely will form a +3 charge. If you have an oxide of -2 and X of +3, then in order to get a neutral compound, we're going to need X2 and O3, right? 3 oxygens, 3 times -2, that's -6. +3 times 2 is +6. That would equal 0 or a neutral compound. So for this, our answer would be C. That's all I have for now. Thanks, guys.